Question number 6, exercise 7.2. It's a figure given here in this triangle. D is given the midpoint of the side AC. So D is the midpoint of AC, implies AD is equal to CD, such that BD is half of AC. BD, this length BD is half of AC. This length BD is half of AC, right? So as you can see, half of AC, I can write half of AC. So this is half of AC can be AD, right? As D is the midpoint, so half of AC will be either AD or DC. You can take any one of them. But as a result, what do we get to know? As a result, we know that this being equal to this given and BD being equal to half of AC, that means these three sides are equal, right? They belong to different triangles, but they are equal. Well, we are going to prove here that this is a right angle triangle, the triangle ABC. This whole triangle ABC, right? This whole triangle ABC, we have to prove it is a right angle triangle. That means we are going to prove angle B as 90 degree. Let's see how we can prove it. Well, we have to keep in mind that this is not based on congruency of triangle, although it belongs to that triangle chapter only. But we'll be using the concept called angles opposite to equal sides are equal. So let's take one triangle at a time. We can take any of these triangle. I started with this one. So I'm considering this triangle, that is in triangle BCD. We have BC is not BC. It is BD. So BD is equal to CD. We can write this as given. So the angles opposite to these two sides are these two, right? Angle 1 and angle 3. So that's right. I'm writing this angle 3 is equal to angle 1. That's by isosceles property. I'm marking this equation 1. Similarly, when considering the other triangle, this one. In this triangle also, we are going to go do in the same way. That is in triangle ABD, we have the length AD is equal to BD, again given. So we can write their opposite angles as equal. So we'll write angle 4 is equal to angle 2. That's again by isosceles property. There's something which all of you need to keep in mind, is that try keeping these two angles on the same side. As you can see, I kept 1 and 2 on the same side. That makes easier solving this part. Now I'm going to add these two equations. That is adding equation 1 and equation 2. We'll be adding the left hand side, that is angle 3 plus angle 4 should be equal to right hand side, that means angle 1 plus angle 2. So 3 being replaced by angle C, 4 being replaced by angle D, and the sum of 1 and 2 from the figure you see, the sum of 1 and 2 is angle B. Right. This is what we got. Now we have to prove it as a 90 degree. For that, we are going to use angle sum property. So we'll be adding angle B to both the sides. Right. We'll be adding angle B. Let's say if I add angle B on this side and same with the other side, angle B. That's used to do in the next step. I'm doing here only. Now, these are the sum of three angles of a triangle, of the same triangle. Look here. Here I'm talking about this triangle. This one. Look into this triangle. We have this angle B, angle C, and angle D as the three angles of a triangle. By using angle sum, I can replace this 180 degree. B plus B is what? Twice of angle B. This implies that angle B will be 180 over 2. So that is angle B is equal to 90 degree. That's how it can be done. So that's what we have to prove this as a right angle triangle. So we proved one angle as 90 degree. It implies it's a right angle triangle.